right, thank you so much, Brittany. Hey, everybody, welcome to this webinar on deploying a containerized workload across multiple clouds. If you've been to any of my webinars previously, you know that I always promise that they're not going to take that long, and then they end up taking over an hour. In this case, I think there's at least a shot that I won't keep you here too terribly long. Obviously, love any questions, any comments you have. We'll be more than happy to take them. I'm going to tell you this. It's kind of a weird thing to start out a webinar talking about, but you know, I'm comfortable saying that there's a really good chance that you can ask me some questions about containers, or I'm going to talk a bit about Kubernetes, and you can ask me questions about those, and I may not have the answer off the top of my head. But I was kind of thinking about that, and I was like, oh man, that's a bad way to be the expert. But it kind of fits in with the theme of what I'm talking about here, and kind of something I've actually been thinking about more as I get some more gray hairs, and that is the fact that, you know, we as developers, we as the people who build workloads, we really need to be able to use tools and use them effectively without those tools really getting in our way. And so I'm going to take you on the journey that I went through setting this up, and talk about it a little bit, and hopefully get a little bit something out of this. And like I said, please do not, even though I just gave this caveat that says you can ask me questions and I now have an excuse for not having the answer, please don't hesitate to throw some questions up in the Q&A, because I will tell you this, that first of all, it's going to make it a more fun experience if we hear voices other than my own, although it'll be me reading the question, but also I will get back to you with answers. So with that being said, let's go ahead. Quick introduction to myself, and hi, I'm Tracy. I am a Azure Solutions Architect expert. That is the cloud environment that I tend to spend my time in, although I'm spending more and more in AWS and also Google Cloud Platform. And more than anything, I wanted to get my contact information up there. Feel free, send me an email if you have questions. Absolutely, reach out on Twitter, reach out on LinkedIn. I'm watching the control bar there for our meeting. Looks like we've got some chats probably coming in there. If you have questions, please throw them in the Q&A, because I'll be able to pick those up as we go. All right. Oh, and I've got a bunch of certifications, but frankly, I've been teaching in the Microsoft environment for now 25 years. I should probably have some certifications, and it turns out I do. Not really important. Really wanted to get my contact info up there. All right, so what are we going to do? This is really going to be a demonstration-heavy webinar, and we're going to take a look. First of all, a little brief overview. I'm an instructor. I can't help having some context, so we're going to add some context there, just talk about different ways that we can deploy our workloads. And then I'm going to go through and I'm going to show you the workload that I have defined. We'll walk through that, and then we'll take a look at actually deploying that workload at the infrastructure level, actually across 3 different clouds. And I'll show you how I set those up, of course, and that'll be actually defining the workload. And then we're going to take a look at defining the workload in Kubernetes. And if you're not familiar with Kubernetes, great. That means I'll be able to get away with whatever I want. I will tell you that I'm going to deploy at the infrastructure level across 3 clouds. I'm going to deploy at the Kubernetes level across 2 clouds, because I got very, very frustrated with one of the 3 providers who shall remain nameless. And then I'm sure if I were a AWS instructor, oh, I named it, I would in fact be deploying it there as well. All right, in the meantime, we're going to go ahead at the end of that, just some parting thoughts, some things that I certainly think about putting this together, and in general, when I start thinking about cross-platform workload distribution. All right, so let's go ahead and let's talk about this. First of all, I'm going to talk about why I'm doing this webinar. And there's a few things. First of all, our marketing department does like it when I do webinars, so we have that. But you know, the number, and I have an asterisk by that. I didn't put it down there because I don't want this in writing. But 80% of public cloud customers are invested in multiple clouds, or at least thinking about it. Now I got that, and I've got this documented in other places, and where it's from, frankly, doesn't matter that much, because people will say pretty much anything right now about the cloud, right? And so 80% is a number. It's a number, quite frankly, I don't believe. But what I do believe, what I think it does represent, is that there is this massive push to really be across multiple clouds, right? And let's face it, first of all, clouds go down. And second of all, as clouds mature, I think more and more they become commodity, right? And I should, as an architect, if I have a particular workload, then I don't necessarily want to be tied to a specific cloud. Now, there may be reasons for that. There may be services or features or benefits that are offered by one cloud over another. But when I'm thinking about architecting my application, I really want to think about that last, right? I want to think about, okay, I have a workload, I have an application, I need to build this application, and I want to have as much flexibility as possible. And so for me, it's kind of important to see that it really is pretty easy to build a workload that can be deployed across multiple clouds. And I'm choosing 3 clouds, but honestly, for most of what I'm doing, this would be across any public cloud provider, or even if you've got private clouds set up. The third point here, containers are amazing. I'm not a container expert. I love containers. I love working with containers. I'm functional with containers, and to an extent, I think that's an important place to be, right? That I think containers can give you tremendous value without having to have that absolute, complete expert level. I know absolutely everything there is about containers. Now, that expertise is necessary, but it's not necessary for everyone. It's not necessary for this webinar, I don't think. And I also think, and this is something that, again, is just more and more something I've been thinking about, is that, we need to simplify when we can, right? We need to simplify the development effort and say, what can we do to really focus on our code? And there's these millions of different things that we can do and add on, but can we separate that out? Can we say, look, I just want to build this really cool application and then worry about plugging those other things in later, and how can I do that? All right, so that's the why this webinar. All right, now what are my options when I think about, and this is not my container option, I'm not going to spend a ton of time on this, right? But if I think about deploying my functionality, whether frankly it's on premise or into the cloud, I have to think about, okay, what are my options for deployment? And one option, and it is still, frankly, the most common option, is infrastructure, right? And if I think about, I'm going to type these out pretty quickly. If I think about all of the different layers that I have for an application, right? I have the workload, right? Beneath that, I usually have some kind of services, database services, web hosting services. I have an OS. Generally below that, I probably have a hypervisor. You can see, rather than just say virtualization, I say hypervisor. You can see my bend towards my Microsoft experience. And then, below that, I've got things like, we could say, all right, BIOS, right, hardware, and also facility, okay? And you can change that around a little bit if you want, depending on kind of how you're thinking, right? Well, if I look at infrastructure, and that's a common term in cloud, infrastructure as a service, right? What's happening at the infrastructure level is that the cloud provider is giving me everything below that line. Right? And so what that means is that I am responsible for everything above that line. Okay? And what that means is if I have a workload and that workload will run within what I can define at the OS level and above, then I've got my workload, I can run it, I'm good to go, right? And really, if I'm running, for example, Ubuntu, or if I'm running Red Hat Enterprise Linux, or even Windows, right? That operating system is going to run the same across different providers. So really, without even going to containers, if I say, look, I just want to run this, great, we're done, end of this webinar, and that'd be really boring, but I'm going to keep you here hopefully for a little while longer, right? But that's the infrastructure level, saying, look, let the cloud provider handle all that physical infrastructure, let them even handle things like the virtual networking and the management of the virtual machines. I just want to focus at the operating system level, et cetera. But I am responsible for that at the operating system level and above. Now, if I take this and I'm actually not going to, let's see here, take that line out. There we go. I'm not going to shift over to platform yet because that'll ruin this and take this away from this drawing here that I've done. But if I'm at the platform level, so now we're looking at the platform level, platform as a service here, okay? Then what's happening is the cloud provider's actually giving me everything except my workload, right? And with the cloud provider doing that, that's great, because what that means is that I just have to focus on my workload. Now, I will say that that comes at a little bit of a cost. Now, all of the major platforms, and the three that I'm familiar with are Azure, AWS, Google Cloud Platform. They all have platform application development services. With Azure, it's technically app services, but most people consider it to be web apps. In Google Cloud Platform, you have the App Engine. In AWS, you have Lightsail, you have Lambdas, you have Elastic Beanstalk. So there are, these platforms that are providing this. And the cool thing about that is what it means is that you don't have to think about anything other than your workload, which is great. I will say, however, that you lose a little bit of flexibility when you just go straight to platform. Now, the platform providers will tell you, and they do, they'll tell you, we host a wide range of languages and development platforms, right? And you can load your libraries and you have various levels of flexibility, but it is a bit constrained. You lose a bit of that control that you would have if you're at the infrastructure level when you go to platform. Now, I'm not talking against platform at all. I use platform as a service all the time. And in fact, it's actually going to be a recommendation that I make at the end of this as something to consider, right? Although we're really talking about containers here. Okay, now let's take a look actually at containers. Okay, and so we'll flip through platform, we'll go to containers. Okay. And there we go. See, it's nice and yellow there, orange. I'm terrible with colors, mustard, who knows. All right, but we've got containers. And what I want to do is I want to go ahead and, first of all, there's a good bit of chat. I want to make sure there's nothing I need. Ha! Andrew Brown, sorry, I have to point this out. Andrew, EKS is fine. All right, so I will tell you, Andrew, I spent 2 hours last night on EKS, and that was, let's just say, at which point I decided that it was no longer an option for this particular webinar after having spent some more time with it. Anyway, sorry, after promising I wasn't going to go into chat, I did anyways. So we'll go ahead and close that. All right, sorry, back to the story at hand. All right, now with containers, right? The really cool thing about containers is that I create this container. Really what I do is I create an image, okay? The cool thing about the image, the container, is that the container's got my workload, right? The container, in addition to having the workload, it's got any services, and it actually has the OS config. Oh, look at that, right on the edge there. Okay, OS config. Now, the cool thing is I can then take that container based on an image, and we'll get to that in a second, and I can put that pretty much where I want, right? So I could say, all right, cool, I want to run this an infrastructure as a service. In other words, I want to run it on a virtual machine or EC2. Okay. I could say, you know what, I want to take this and I just want to run this. I just went the wrong way. Oh, good. As I learn how to use my tools. All right, and say, you know what, I want to run this as an orchestrated solution. Terrible. There we go. As an orchestrated solution, or I can say, you know what, I might even want to run this as a straight platform solution. And I'm writing this out like it's the cloud. I mean, the reality is that I could run this on-prem as well. And that's certainly where I'll probably end up developing it. Okay. The cool thing is that if you're not familiar with containers, and in an hour, and what I'm trying to do is not enough time to go in any way deep into containers, right? I can build that, and I use a Windows machine, as I see half my people leave when I tell them that. I use a Windows machine, I use Visual Studio Code, and I can build a container on my machine, run it and test it on my machine, and then package it up as an image, and I can deploy it wherever I want. And that's, to me, a huge advantage of working with containers. Now, kind of taking that to the next level, right, is we have this idea of a CI/CD pipeline, right? Saying, okay, maybe that's enough for me, maybe it's not, but you know, I've got my dev environment here, and then I've got a pipeline, and I'm going to be real vague on this because we are not going down the CI/CD road right now. CI/CD, I'm sorry, continuous integration, continuous deployment, or continuous delivery, depending on what you're doing. It's standard concepts that are generally associated with DevOps. I hate when people start throwing out acronyms and they don't explain them. So there we go. I've caught myself. You're welcome, or I'm welcome. All right. And the idea with this is that I've got some sort of target here, and developer, they work on code. Typically, they then check that code into some kind of repository. That kicks off an automation process, which is really, really what this is. It's just automation. It can be a whole bunch of things that go on, checking for your code completion, testing, making sure you've got security checks, all sorts of stuff. And then eventually that's going to deliver it down to a target. Okay. Now that target could be a cloud service, that target could be an infrastructure, could be a virtual machine, it could be just a machine running on your own local environment in your own data center, right? I will tell you, I use these, and again, this is something that I'm knowledgeable with, but I would not consider myself an expert. I use pipelines as a tool. When I first came into INE and I didn't have any kind of demo environment, I actually built up this demo application environment ecosystem, and I had the whole thing tied through Azure Devops with a pipeline that delivered it out to some web applications that were running in Azure, as well as some containerized solutions, right? But the idea is that I have this ability, whether I'm looking at running from the standpoint of more traditional infrastructure where I'm going and I'm installing things, or the platform where I'm using platform services, which give great value with some caveats. If I'm going with containers or pipelines, both of those give me this really approach that spans across platforms, lots of different options for deploying my workload, my code. And that's really what this is all about. I know this was supposed to be all about containers. It will be from here on out. Okay. Now, what are my cloud container options? All right. So we know that we have these different ways that we can deploy our workloads, right? Whatever that workload is, all the way from having it, very traditional, deploying it onto virtual machines or core machines, all the way up to platform or automation. But what about containers? Well, you'll actually find that the options there are pretty similar. They track pretty close to the options I was just talking about. If we're talking about cloud containerization, one approach, and it's a very common approach, is to say, all right, I know that I can run cloud platforms on infrastructure, so let me just go ahead and do that. Let me just spin up a virtual machine, or let me spin up an EC2, and let me install Docker, and then let me run with that, right? And that's one option that we have, right? And then we also have platform hosted, right? And what this is really an approach saying, okay, you've got containers, you want an easy way to host these containers, to deploy these, and the different cloud providers will give you that. You've got web apps in Azure actually allow you to deploy containers directly to the web apps. Azure also has Azure container instances. You've got within Google Cloud, you've got variations of Kubernetes from really fully managed and orchestrated, which we'll get to in a moment, to really very much just one-off and simple. In the AWS, you have a variety of options, including Fargate, which has by far the coolest name for any of these platform-hosted container solutions. The idea with the platform-hosted solutions, at least for me, right, and what differentiates them from, say, infrastructure hosted or our next option, which is orchestrated, is simplicity. And the reality is, I think about how many workloads are, when it comes down to it from a hosting standpoint, relatively simple. Maybe you've got a few services. Maybe you have a monolithic API server and you have a web front end. You don't need massive amounts of orchestration. You just need somewhere to run your code, right? And for me, that's where the platform hosted can be really useful. And what I like about the platform hosted combined with the container concept is that you get that ease of use and that minimal administration with the platform, but you get the complete flexibility of having a containerized solution, right? Because I can build my container, and honestly, particularly if it's a Linux-based container, it's highly likely that container is going to run anywhere you can run a container, right? So I can take and say, all right, I'm going to encapsulate my functionality, my workload in this container, and I'm just going to go drop that container off in a in a platform service. Now, at a more sophisticated level, you have hosted orchestration. And in the various clouds, all of the clouds that I've worked with have the ability to host what's called Kubernetes. Now, you may or may not be familiar with Kubernetes. You may see K8s, which as much as I've railed against that as being completely non-intuitive, I now use it. But it is a massively scalable container orchestration system. It is designed to say, look, not only do I have, and I'm going to use a technical term here, a whole bunch of containers, but they need to work together in certain ways. Some need to be exposed, some need to be internal, and I may need to scale them out to tens or hundreds of thousands of instances of these to handle the scale of my application, right? Now, I'll make the argument that, that hundreds of thousands of instances, if you are Netflix or if you are running massive scale machine learning, then, those hundreds of thousands of instances really matter. If you're not, then, and anyone who's a massive Kubernetes person, turn off your earphones for a moment. Honestly, I think you want to consider whether you really need to go to that level. All right, and I'm probably going to get hate Twitter mail, whatever that would be called, hate tweets, for saying that. But for me, again, the really cool thing about containerization is that it makes it really easy to host your workload. Okay, and so keep that in mind and think about, okay, what is your workload? What are the scale requirements for your workload? And what level of sophistication do you need for that? All right. Now, there's also third-party options for this, and you've got things like OpenShift from Red Hat. You've got DCOS. You've got Cast AI, who 100% I included in them in this because they responded to a tweet about this particular webinar. So I just thought that was pretty cool, so I threw it in. But and I don't know anything else about them because I didn't bother to look. But the point is that there are third-party solutions out there that are designed to make this process easier. So all of this, what's the point? The point is that containers are awesome, and you can deploy your containers to the web today, to the cloud today, and you have a lot of options, right? From saying, okay, I want to manage everything at the infrastructure level, right? Or, I just have a container. I need it to run somewhere hey, I've got a really massive scale system that needs to be able to scale at an enterprise level and be managed at an enterprise level. Let me look at these hosted Kubernetes based. I say Kubernetes in fairness to AWS, Azure Web Services. They actually have two different versions. They've got Kubernetes, and then they also have Elastic Container Services. Okay, so but they do kind of similar things. All right, so there we go. By the way, I see there is some traffic in the chat. Again, if you've got some questions, if you could pop them into the QA, that would be absolutely fantastic. All right, now another thing you want to think about, and I threw this one in here. I'm going to keep this fairly short, but you'll see why I threw this in here in just a moment. All right, always think hybrid, right? When you start thinking about going into the cloud, when you start thinking about a solution in general, on the one hand, you don't want to overcomplicate things. On the other hand, you want to use the best tool for the problem. And containers are absolutely a solution. They're not the only solution, right? And when you start thinking about deploying to the cloud, the idea is to make the entire, not just the development, but the entire lifecycle management of your workload as simple as possible, right? And so think about platform services, data services. All of the providers have platform managed databases, right? And so I can go, frankly, whether it's with relational database services on AWS, Azure database for MySQL, or in Google Cloud Services, and I know the other providers have them as well. If I'm using MySQL, then I can actually spin up a MySQL database in no time, have that fully managed, so I'm not worried about the database. I am simply worried about my workload. And really, other than possibly changing a connection string, it's not impacting my workload, the way I build my workload, where that data source service is. And you'll see the same thing for storage services, large-scale file storage. Think about all the images for your web apps. Messaging services, as you build asynchronous, loosely coupled application architectures. Do you want to host your own messaging system? Certainly you can. You can host that in a container. Or do you want to use one of the systems that are already part of really all of the clouds? Okay, and then also consider hosting services. Look, if you're writing something in Node.js, then you can just deploy that. I love containers. You don't need a container for that. You can just deploy that right there directly to your hosting services, including, I have there in quotes, serverless, because nothing is actually serverless. There's always a server. It's just whether or not you actually have to manage the server. Totally different subject for a totally different day. All right. Now, really, for me, what you want to look at is think about platform and infrastructure as commodities. And in my mind, containerization helps with that a lot, right? Because if I have a specific workload and I can put that in a container, I can run that container wherever. I'm not tied to a specific provider to run that container, right? Because if there's a provider at this point that doesn't run containers, that provider is going to get overlooked, okay? And so you think about that. Now, if you do start to, and this does start to get a little bit complicated, which I know goes against my first principle of keeping it simple, but if you do start to look at saying, hey, I've got a lot of relational data, or I've got a massive set of MongoDB data, right, that I don't want to manage that in a container, right, then you say, okay, let's think about hybrid. but also start thinking about the networking aspect of that. And we actually have some content at INE. First shill all, I'm half an hour in. Sorry, it's going to be long. First time I've shilled INE there. But we also have a few, if I must say so myself, pretty cool webinars where we look at actually using some networks, a pretty simple networking to tie multiple clouds together and host our workloads across them. But I digress. All right, let's get to what we're half an hour in. I made you sit through a half hour of that before you got to the actual fun stuff. Here's the fun stuff. All right, the demo workload. Here's what I have. I have a containerized, fully containerized workload that has 3 components. Okay, I have a web application. This web application is an ASP.NET Core. It is not ASP.NET 5 because that's been a bit wonky for me. It's an ASP.NET Core MVC written in C#. Okay, and developed on Windows. No I in Windows. All right. Now, I also have a relational database. I also have a document database. My relational database is SQL Server. Should have been MySQL, but I still know SQL Server better, and it was quick, so I put it in SQL Server. Please forgive me. And my document database is MongoDB. All of these are set up as containers. So I've got a container for the actual web application, I've got a container running SQL Server, and I've got a container running MongoDB. And in any of these architectures, I need access to the web app on port 80, because going through the process of setting up a certificate and getting everything installed there really was outside of what I felt like, what I thought it would be good to show you. So I didn't do that. All right, so this is the workload. Simple, 3 related containers that need to work together, and I want to be able to deploy them as a unit. Okay. Now, a couple things about this. First of all, this is an absolutely terrible architecture. It is a terrible architecture because, well, deploying MongoDB content and relational database content via a container is not necessarily the way you want to go. Not saying you couldn't run them in containers, but the way I have them deployed is pretty terrible. If I was doing this for real, I would look very hard at using those as services, but that would sort of defeat the whole purpose of this demonstration. I could have also gone and done a more realistic demonstration where I had a web application and a separate API server running as 2 different containers, but I'm just going to be honest here. I had to put this together in a timely manner, so this made more sense. There are definitely some things that are not covered here. Not going into security. This has got, I will just tell you right now, absolutely horrible security, including plain text connection string with an embedded password that I'm going to show you, but I'll never use it outside of this. Nothing on CI/CD. Again, no security whatsoever. And also didn't really look at any kind of integration. So, looking at, okay, what would maybe be a better way to host the database? It's good for an example though, because you can see a workload that uses multiple containers, uses them together, and deploys them together. And that's really kind of the point. Okay. All right. And so now we're going to go ahead and we're going to take a look at actually defining the workload. And what I want to do is I actually want to start and say, all right, I've got 3 different platforms here. I've got a Azure platform, I've got AWS, and I've got Google Cloud Platform. Now, of these 3, I think I am not being immodest when I consider myself an expert in the Azure environment. I am not an expert when it comes to either AWS or Google Cloud. But again, I think that's kind of the point. I can actually carry this off without being an expert in those cloud systems. Please consult an expert if you were to do this with a production system. Absolutely. But, all right, so what if I wanted to deploy this at the infrastructure level within Azure? And full disclosure, I've already got the virtual machine deployed. But what I would do in Azure, I'd say, okay, I want to deploy this. I want to manage everything from the OS and above. So I can say, all right, I'm going to go ahead and pop in, and I'm going to provision a virtual machine. Again, other ways to do this. I'm huge on infrastructure as code, and there are templated ways of doing this actually across all of the platforms. But I just wanted to show you kind of, what the components are, and I want to do it visually. And the having the portal here, the consoles, makes it kind of easy to do that, right? So long story short, a bunch of settings. What image do I want? What size virtual machine? What are some of the core things like security rules and username and networking and disks? And I could literally just kind of go through here and set this up and click through and create. Okay, it is absolutely a clickable process. Now I've already done that, and I already have a virtual machine set up like that. Okay, now the same thing if I'm doing this on the infrastructure level in AWS. Really the same idea. I can come in here and say, you know what? This is, by the way, I'm logged in now to the AWS console, and I can say, I want to launch an instance. And without going into too much of the details, it's going to give me kind of the same basic kind of experience. Okay, where do I want to start? And let's say I want to start with Ubuntu 18. Okay, and pick a size. Define details like networking and how many instances. All right. Don't join a domain, all sorts of different instances or different options that I have. And I know I'm going through this quickly because, again, it's not the point to show you how to create a virtual machine, or EC2 in this case, but the point is it's pretty easy to do. And there are tons of ways to do this. I'm going to cancel out of here because you get the idea. And then really the same thing over here in Google Cloud Platform. Okay, so I can go to my compute engine, and in the compute engine, I can create a virtual machine here. Okay, and again, the same thing. What size virtual machine? Where do I want to put it? What boot disk do I want? So let's say if I don't want Debian, I can go over here and say, you know what, I want Ubuntu or even Windows Server, whatever it is I want, and set that up. Okay? So the point is, all of the settings that I need, very easy, literally under a minute once you've done it once, to create your virtual machine across these different platforms, right? So that gets my infrastructure set up. Now, similar story, really, if I want to go with a more robust hosting, such as, let's say, Kubernetes, right? If I'm in Azure and I want to use Kubernetes, you say Kubernetes service. So I want to create a Kubernetes service. Okay. And I'll go through a little more on this one because I think it's a little more specifically applicable. All right, so look, I'm going to put this in. A resource group is just the way Azure manages resources in a group. All right, so I give it a name, a region. It's got high availability set up, although I wouldn't use high availability because like I said, look, I just want one node. Notice the machine that it's running on. And then what size do I want, right? Standard DS2, so this is going to give me processing. What's interesting, somebody else, I was sitting in on a meetup last week, and somebody I was talking about as an Azure developer, what are the things that you should think about, and brought up Azure Kubernetes service that we have here, and mentioned it that it's kind of a quasi platform as a service, and I think that's dead on. Across any of the platforms right now, it's a lot easier to provision a Kubernetes instance as a quote unquote platform resource, but it's still a lot more work, and you're a lot closer to the bone than if, say, you were using, an app engine in Google or Elastic Beanstalk or a web app in Azure. So it's kind of got that, sits kind of in between being a platform service and an infrastructure service. All right, so I would go through and say, all right, we have that. I only want one node. All right, and then I can say that node runs as an agent. Again, a node is really just a machine that's running underneath the Kubernetes. You've got the control node, and then you have agent nodes. And then those agent nodes are organized into pools. Okay? And that's really all that is. And then you go through other settings like authentication. Now, what's interesting, and this is across all the platforms, because Kubernetes is really tied in there at that infrastructure level, the Kubernetes control system actually interacts directly with the cloud, and you have to give it rights to do so. And that's all this is doing. Okay. I would set up the networking and how is Kubernetes going to interact both internally within the cloud environment, but also providing an external environment. And I know I'm going through this very quickly, and because it's not a Kubernetes class. I just want to show you what's here. Okay. All right, and then I go through, and that's literally it. I would just go ahead and create this. Tons of other things you can do, but that's a process to just go through and create it. And I've already done that, and I've got a Kubernetes cluster sitting there, right? And then kind of the same thing on the Google side. It's actually easiest, I think, in Google to create a new cluster. Probably not entirely surprising, seeing as Google they absolutely created Kubernetes and then made it open source. Okay? And if you just heard something, my phone just picked up the fact that I used the G word and thought I was talking to it. Sorry about that. Don't let any of our cybersecurity instructors know that my phone picks up that easily and listens to my voice. All right, creating a Kubernetes cluster here, also very easy. Go through and say, all right, give it a name. Where do I want it? Okay. How do I want it running? Okay. And updating. And I can go and say, okay, what about my node pools? How many nodes do I want? Size and image and just configuring it. And honestly, I take pretty much all of the defaults here. Okay. Allow default access. Again, all these are things that if you're in a production environment, probably want to be a little more careful with, but it's pretty easy to get through. Now, if I wanted to do this on AWS, okay, and I know that there's at least one person in here that finds this a fairly straight process. Okay, here is the process that I would have to go through on AWS, which includes bouncing back and forth between a command line infrastructure and possibly using the console as well. But it is possible to do, I'm told. I just failed at it, so we'll leave that alone. All right, now what is my workload and how do I get it there? Okay. I am not even going to go over the workload because that's not really critical because it's rolled up into a container. Okay, but if you are familiar with C# or ASP.NET in general, then you know the components. It's a ASP.NET MVC application, very simple one. You'll see it in just a few minutes. Okay, and by the way, the tool that you see here, this is Visual Studio Code. It's what I use for pretty much everything now. I have a number of extensions added into this, including Docker extensions and Kubernetes extensions. And those are important. I'll tell you why in just a moment. Okay. Now, I built and tested the code directly on my machine running ASP.NET Core. Okay. But then I said, you know what? I want this to actually generate a container. And so what I did is I built something called a Docker file. Actually, saying that I built it is completely wrong. I didn't build this. This was given to me by the system. I literally right-clicked. Actually, I hit F1 and I said Docker, and I selected Add Docker Files to Workspace, and it generated this file for me. Okay, and what this does is it builds a Docker container that can run anywhere that is hosting my workload. Just that workload bit of it. Okay, but this is a multi-container solution. So I also built up a Docker Compose file. Now, this Docker Compose file, I feel fair saying that I built it because I did. Now, I used IntelliSense that's available to me in this tool because otherwise I'm doing a lot of lookups. And I'm going to tell you, I'm not a Docker Compose expert. Right? I use tools. I use tools to get me as far as I can before I need to go and look things up. Okay? And by and large, and I didn't use exactly the output directly, but I've got 3 images, or I've got 3 containers. Okay, one container is actually built based on my Docker file. All right, it's exposing port 80, and it has some environment variables, including, that's right, I'm going to show you right there, my connection string with a password. Don't do this at home. Okay? We'll talk more about that. And then I've got a couple of other images. Now these images are actually up in Docker Hub under my Docker Hub account. I've got a MongoDB image, and I also have a SQL Server image and some environment variables. Again, all of this was really relatively easy to set up. Okay? And then last but not least, I have a Kubernetes control file. Okay, so I've set up a Kubernetes control file. Now this could have been far more complicated. Okay, I set up what's called a pod. A pod is an organization of containers that run in the same space. Okay, it's interesting the way it works. Okay, but I've got this one pod, and these guys can communicate to each other. I could have separated that up into separate pods, one for each one of my containers, and then I could have had internal connectivity for that, but I wanted to keep it simple. Okay, so all of that says, if you're a Kubernetes person and you're pounding your desk right now saying, why are all these in one pod? Because I wanted to keep it simple. All right. Now let's see. I see I have quite a bit in the chat. I want to make sure I'm not missing. I've got some questions coming in from Facebook. Awesome. Okay. But so that's it. All right. So my core, really, when it comes down to it, I've got my core functionality itself, right? And that's my application. And then I've got these files, one file that says, okay, take my application and make it really make it an image, a Docker, a container image that I can create containers on. And then I've got this Docker Compose that says, look, if you're running on a Docker machine and you've got Docker Compose installed, here's all the things I need, put them together, right? And then I've got, hey, if you're going up the next level and you're going to Kubernetes, here's a file to make all that run in Kubernetes, right? And I'm not, as I said, an expert in either one of those, right? I use tools to put these together relatively easily. The point being, if you've never seen this before, right, you can do this, all right? Now, a couple other things, just because they're here, okay? If I'm setting this up, right? If I'm setting this up on the infrastructure level, so if I'm setting up virtual machines to run this, then I'm going to get probably a vanilla virtual machine running an operating system. Now, I could have customized images that have all of this installed, but I'm saying, look, let's say that all the cloud provider is doing is giving me an operating system, all right? So what do? Well, what I do is I install 2 things, Docker and Docker Compose, okay? This is literally copied and pasted from Docker's documentation on how to install Docker on Ubuntu. Okay, I use Ubuntu because it's what I use, and this way I don't have to rebuild this script. Okay, so I've run this script on all of those virtual machines, and I have Docker installed, and I have Docker Compose installed. Okay, now what I'm going to do, you finally get to see something, is I'm going to go ahead and I'm going to start this up, and I'm going to start this up across my virtual machines, and I am able to connect to each one of these virtual machines. All right, this is my Azure virtual machine, and what I'm going to do is I'm going to pull down a copy of that Docker Compose file. Okay, so I just pulled down that Docker Compose file, and then I'm going to go ahead and I'm going to pull this up. All right, and so it's pulling down my images while this goes through. A few minutes here while that starts up. Let's see any um, any questions here. I've got a few questions. All right. First of all, on pipeline, do we need to be or look at DevOps and Jenkins as build, test, and deployment? So, need to is an interesting question. I would say no, you don't need to do that. I would say that pipelines are designed to make your life easier. I think that as developers, and using tools that are available, there's a lot of benefit in defining a pipeline from your, development environment up through getting something deployed out into at least a test environment. I think it gets certainly a little bit dicier when we're talking about deploying into production. Okay, and I realize this is not an answer, but the simple answer is I would strongly encourage you to start to look at DevOps tools, right? And I say DevOps tools because DevOps is much more than tools, right? But I don't think you need to be a DevOps master to take advantage of some of the tools. If you can take advantage of the tools and really implement that in a larger DevOps environment with a DevOps philosophy, that's fantastic. All right, what do we need to learn to become DevOps? Oof. I'm going to take that one. I'm going to take that one at the end. Okay. And my excuse is that this has finished running here. Okay. Now, what I can do, I've got my workload up here, and I'm going to come over and I want to take a look at my container. And in particular, I want to get this public IP address. Okay, because that's now running, and it should. And there we go. Okay, see this incredibly well-defined web page here. Okay, notice it's INE quizzes. All right, this workload may eventually give me the ability to have some live quiz fun when I'm doing webinars, and also we're bringing back boot camps possibly. And so it'd be great to say, hey, let's do some quiz questions here live and together. It's not there, all right. But this drop-down list, you'll have to take my word for it. I promise it is. This drop-down list is coming from a relational database. Okay. Now, if I click load documents here, what that just did was it took two files and it loaded two JSON files up into my MongoDB. And then this pulls them down and displays their content. Not exciting. But the point is, I've got this web app that's exposed, and it's interacting with both a relational database and it's also interacting with MongoDB. Okay. So we've got that guy. That guy's running. Now, I can actually do exactly the same thing in AWS EC2. Okay, I'm going to connect up to my AWS box. Sorry, running. So now I'm connected to that, and I'm literally going to do exactly the same thing here. And copy that. Okay, pull down the file. It doesn't yell at me about multiple lines. We'll just copy that. And there we go. Now, I'm not going to wait for you. I'm not going to make you wait to see this. I think I put this on a slightly better machine. But you'll see it's going through exactly the same process. And again, I can do exactly the same thing here. Okay. This is my interface to the virtual machine that's running in Google Cloud Platform. All right. So I've spun up a virtual machine. Okay. What do I want to do here? Well, I want to do exactly the same thing. Okay, so I pull in that Docker Compose file. And yes, you guessed it. I'm going to run it. Let's just see. Hey, there we go. All right, so I've got those files up in AWS. Let's go ahead and check out AWS. Let's just make sure. Let's go to my instance there. And let's get the public. There we go, open address. And hopefully, I think I may not have set up. I don't think I set up my networking rules right on this one. Darn it. Let's see. Should be running right. Okay. So I think, no, should be letting in there. All right. Well, that's unfortunate, but I'm going to ask you to take my word on the fact that, generally speaking, that that usually works well. Looks like I'm going to have all my problems with AWS today. All right. Now, what I'm going to do is I'm going to go to my virtual machine instances on Google Cloud Platform. And go to my container host here. And let's just go back because I can get it right from there. External IP address. There we go. And wonderful. Moral of the story is only use Azure. Nothing else works. No, that's not true. All of this worked wonderfully when I was prepping it. All right, let's see. That's my AWS is good. That should be good. All right. Let's see what I did wrong. Okay. I'm very excited that this is going so well at this point. Ah, there we go. Allow HTTP traffic. So one thing, I apologize, clearly it's completely impossible for me to do a short webinar. Whilst that, there we go. All right. Once I actually allow the traffic, here we go. We can see that I've got traffic going to the URL, and you can see that it is exactly the same functionality. Okay, so I've got 2 out of the 3. Let's check. That really should be allowing me to go. Got port 80 coming in. See if it prefers the URL there. Shouldn't. Yeah, okay. So tell you what, while that's going on, let's just take a quick look at how I would process this within Kubernetes. Okay, so long story short, on the Azure side, I've got my Kubernetes is running, and it's actually pretty cool. If I go over here and click connect, it actually gives me all I need to do to connect up to this Kubernetes host. Okay, and I've already set that up over here. Okay, and so then what I would need to do here is I would need to apply that YAML file. Okay, so I apply that YAML file, and then get pods. So my actual pod is already running that has my 3 containers, and I get my services. All right, I've got my service set up, and it's providing a front end for those. Make sure I get this right. Okay. And there we go. Okay, so that's now running against my Kubernetes in Azure. And last but not least, and I promise, I apologize for AWS people. I promise that worked earlier. Please take my word on it. It's a connection thing, not a container thing. Okay, and if I go to Kubernetes engine, clusters, I go to that cluster I'd already deployed. I say I would like to connect to this cluster, and I would like to connect to this in their Cloud Shell. It's going to set up their Cloud Shell so that I'm going to work with Kubernetes there. And I'm going to upload my file, right? And so I know I'm going through this a little bit quickly, but hopefully it makes sense, right? I have connected up. Now I used the tools. Let me take a step back because I did go through that fairly quickly. On the Azure side, what I did was I've got the Azure CLI set up, okay? And there's an Azure CLI command that will set up your connection settings for the Kubernetes CLI. So I have the Azure CLI installed on my machine. I have the Kubernetes CLI installed on my machine. I ran a command from Azure, the Azure CLI, that sets up my configuration and connectivity for the Kubernetes tools. And then I use the Kubernetes tools to apply my Kubernetes control file. And then I'm doing really exactly the same thing here for Google, but rather than connect up to Google on my local machine, I'm using their cloud interface for doing that. And it just simplifies a step. It makes things nice and separate. And what I'm going to do is I'm going to go ahead and upload this Webinar Cube YAML. And we'll make sure that's here. Okay. Actually, I forgot to delete the old one, so we can just run with that. And I probably, there we go. All right, so I am going to apply that YAML file. So it's the exact same YAML file. I apply it. Okay, and now if I go kubectl get pods, my pods are running. Get services, my service is running. There's that external IP address. I'm just going to take that. And there we go. Same thing, running in a different place. Okay. So I've now taken my workload, which includes 3 containers based on 3 different images. And I've deployed this to 3 different clouds. You couldn't see the result of one of them, I promise it did. All right, to Azure, to AWS, to Google Cloud Platform. I deployed this at the infrastructure level by simply having virtual machines and installing the software I needed on the virtual machine to host my workload, and then deploying that workload using Docker Compose. I also deployed it at the quasi-platform level through Kubernetes, right? So I have in both Azure and Google Cloud Platform. Not having AWS is my fault, not AWS's. But I've got Kubernetes installed on both Azure and Google Cloud Platform, and I can deploy my workload to either one of those. Hopefully you see how valuable this is, right? How useful it is that you can go and say, you know, I have this workload. I want to think about my workload. I don't want to think about where that workload is going to be hosted, right? And know that you've got these options to take your workload and be able to deploy it across really any platform that supports containers. Okay, that's the important part of this demo. So we define the workload, we deploy the workload to infrastructure, deployed it to manage Kubernetes. All right, some parting thoughts. I had to include this. One of the people on this conversation at least was at one point in this webinar. I appreciated the shout out, but I also was pretty amused by this. So I sent this out, and somebody responded down here, a tour summarizing this webinar, a tour of some of the worst user experience available. And I put that out there because, hey, I just thought it was kind of funny. But also, it is something to keep in mind is that, you know, I'm not the only one that's going to say this. Kubernetes is amazing. What it can do at the enterprise level is just absolutely astounding. Okay, but it's also kind of hard to work with, you know, and really the tooling around Kubernetes is not yet where some of the tooling around some other hosting capabilities you might want to use, right? You know, if I'm writing something in Node.js, I click a button and get it up wherever I want, not have to think about anything. Mostly the same is true for C#, which is where I tend to live. Okay, so yeah, Kubernetes is amazing. It's incredibly powerful. It's also not something you're just gonna step in and use, clearly. Okay, now some of the other things. First of all, don't think about anything as being completely cross-platform, right? There's always a balance. You know, if I containerize my solution, then that's something that makes that solution really flexible and where I can host it. But I do want to think about the fact that there may be better, easier solutions out there for some of the elements of that solution, right? And I've already talked a lot about the fact that, you know, I would use platform services for the database. I'd probably shift over to MySQL just because everybody uses MySQL, and that's fine. MongoDB, I would probably use that at the platform level as well. Some other things in terms of improvements to this beyond just the, you know, not wanting it to be completely cross-platform. Definitely think about security a little bit more in terms of where I would go with this, some things that weren't included there. Think about key storage or at least secret storage, you know, and that's something certainly within Kubernetes that your Kubernetes has a component for that that could be tied into, say, a real key storage solution within your platform, right? But that starts to get away from being completely cross-platform. But that's something where I think it'd be totally worthwhile. Definitely some actual container image management. I would not, if this were a production solution, be putting this up on Docker Hub. Docker Hub's great, right? But I'm going to be managing my own, it's called, if you're not familiar with it, container registry. That's just where you store your images for containers. I'd be managing that probably on one of the platforms because you can do that pretty easily. And then I would definitely 100%, if I was doing this, look at setting up a pipeline, look at implementing some infrastructure as code. You know, what I did this morning, shortly before this demonstration, is I literally manually went to all my virtual machines and just ran this code, copy pasted it into the virtual machine. It's just easy to do that, right? And you know, the same thing you saw as far as the way I deployed this. But you know, if I'm doing this at any kind of scale, I'm going to automate that. You know, and that way, I don't also run into the, oops, clearly I forgot a setting in AWS, so you couldn't see the fact that it was in fact running properly in AWS. All right, so that's it. 10 minutes past. I've got a number of questions. I know there's a few over in the chat as well. So what I'd like to do is go ahead and just start hitting some of these. And we'll put this up on the nice little intro screen here. All right, so I'm going to go back through the question. The first question on pipeline: do we need to be or look at DevOps and Jenkins as build, test, and deployment again? It's something I would recommend. And do you need to learn to become, what do we need? The next question is, what do we need to learn to become DevOps? I think personally, there's you know, when you talk about DevOps, there's DevOps tools, right? And then there's DevOps. And the whole idea of DevOps goes beyond a set of tools. It's just kind of like the idea of, you know, Agile is more than just having morning stand-ups, right? You know, there's a lot. That's a hard question to answer. You know, honestly, there's tons of DevOps courseware out there. If you are an INE customer, we do have some DevOps. That is certainly actually one of the cloud pillars that we're actively working on improving within our environment. There's also honestly tons of other stuff out there. That is not a great answer, but I would say, you know, at a minimum, you need to start looking at, if you're a straight developer and you just want to think about the tooling, that I can answer. You know, start out, don't tell anyone who said this, I'm not a huge fan of Git, but GIT, the code management system that is now completely ubiquitous, but you need to learn that, right? And then look at having centralized code management, whether it's through GitHub or another centralized code management system where you can push your changes into that system, right? And then look at pipeline software. Jenkins is one example. There's other pipelines out there. Actually, GitHub has a built-in pipeline capability. Certainly, you've got that kind of automation in the various clouds. You know, I would say Jenkins is a good place to look, and I say that not being a Jenkins person, because it's not tied to any particular platform. But you would need to know that and understand endpoints as well. Okay. Now, some other questions here. Do you also, these are all from Anonymous, so hopefully I'm giving you a good enough answer on this. Third question down, do you also need to specify the master and work nodes as well? So when you are defining a Kubernetes cluster as a managed cluster, okay, generally speaking, and I absolutely know this is true for Azure, and I honestly did not look to make sure this is the case for both AWS and GCP, but the what is called the master, the control node, right? That's going to be managed fully by the provider. Okay. Now you can do things like what version do you want and a few other settings. By and large, though, you're really defining that as part of the process of defining that cluster. Okay. As far as your agent nodes or work nodes, yes, you are going to do that. You're going to define what size nodes. You can have different characteristics of nodes with different node sets, but you are going to be the one responsible for that. Although, for example, AWS actually allows you to use Fargate, again, best title of any of these systems, where you have a much more on-demand and quote unquote serverless solution. So if you're using AWS and you're using Fargate with that, you're not going to specify the node configuration per se. Okay. Next question, I take it this config file is YAML. That is true. Every configuration file that I showed you is YAML. So the Kubernetes is YAML. If you're not familiar with YAML, reach out to me, talk to you more. There's tons of good sources on it. This is becoming a fairly common de facto standard. I think I'm still enamored with JSON myself, but I get YAML and why it's used, but both the Kubernetes as well as the Docker Compose, both those are using the file structure specification known as YAML. Okay. Once the pods are created, will we need to create service files to access them? Better to manage the pod? That is a great question. And the answer is hopefully not, right? You can certainly, and there's examples of this. You can find examples of this in Kubernetes documentation, where if I need to go and actually run commands directly on a container in a pod, you can do that with Kubernetes. Generally speaking, I'd recommend, kind of trying to avoid that just from a philosophical standpoint. And I mean, I guess you're asking a service. So in other words, should you create a service with port 22? I would never do that, right? I just don't want to expose my administrative endpoint that way. Technically, I guess you could, but again, not something I would personally recommend. So I'm not sure if that answers that. I would not, so my answer to what I think the question is related to creating a service for file access, I would not create a service for administrative access to the pods or their containers. If I need to interact with them, I would use Kubernetes commands to either run commands directly into containers through Kubernetes, or, for example, I may want to monitor the logs and just get the standard output and monitor the standard output from the containers. All of that can be done through Kubernetes itself. Last one. Should focus on specific DevOps tools or check other tools that suit for workloads, and any suggestion on that? Great question. So, and it's a question, I'm gonna just be honest with you, I don't have a 100% answer on, because I'm kind of two different minds on that. On the one hand, I think, the more that you are not tied to a specific tool, the easier it is to kind of pick up in any environment. On the other hand, every tool you learn takes intellectual overhead, right? It's going to take learning that tool, and it's going to take actually remembering, either A, what are the commands, what are the processes, or remembering where do I go and look, and every time I need to use this tool versus that tool, I'm going to need to look up those commands, right? And so I think my recommendation would be, to go and use the tools that make the most sense for you. I'm gonna give you my next bit of advice with the absolute caveat that my main area of expertise is Azure, and I've been a Microsoft instructor for 25 years. Okay, for me, what I'm going to do is I am going to use tools like Visual Studio Code, and I'm going to use extensions on Visual Studio Code that let me work in Visual Studio Code and say, you know what, I've got some changes here. I need to go ahead and commit these with a really awesome, just in case you can't see the incredibly descriptive commit message I have there, more changes. That's my commit message, right? But aside from the fact that that's terrible, I'm gonna go ahead and commit those changes. And then I'm gonna go ahead and publish those to GitHub. Now, sure. I just said publish to GitHub, and it, I believe, just created that repository for me on GitHub, right? And so, I've got a tool set here that requires, frankly, very little specific knowledge of the tool set. And I've got some great stuff like, hey, I can see what my commits are. What are my repositories? There we go, right? And then, GitHub has the ability now to actually set up pipelines. I have to sign in to get there. But, and then what I'd probably do on the pipeline side is I'm probably going to build my pipeline in GitHub. Now, I've used Azure DevOps, love Azure DevOps, but at this point, honestly, my money's on GitHub just because Microsoft bought GitHub after they did, set up Azure DevOps, and I have no inside knowledge on that. So if anyone in Azure DevOps hears about that, please understand, no disparaging intended. But there you go. That would be my answer to that. What does all that say? Learn, probably, as much as I hate saying this, it's probably better for you to learn some specific DevOps tools. Look at what's going to work with the environment that you've already set up. Certain things are universal. At this point, Git is universal. You may or may not want to use GitHub, but GitHub is universal. Jenkins is universal, right? So, I mean, there you go. If you want to, talk about a tool path that you're probably not going to go wrong learning, that would be a good tool path to learn. All right. Those are, I believe, all of the open questions in the Q&A. I know there was a fair bit on chat, so I'm going to pop over to chat. Well, there's a lot in chat here. All right. Let's see. Elastic, some great stuff from, I'm going to give you full credit here, Andrew, because I think I'm the only one that can hear it. Put some great stuff out there. Hopefully you're still here. Elastic Beanstalk can host containers as well, so it could be under platform hosted. App Service can run containers as well. That is absolutely true. Azure makes it really easy to use DCOS. That is true. EKS and ECS are going open source, so you can run them on premises. Those were all from Andrew Brown. I'm not sure if you're still on, Andrew. Good guy to follow on Twitter. From INE, another question from Facebook. Are there egress charges involved for using Cloud Pass IaaS connecting to on-prem? Fantastic question. So the question is, are there egress charges involved? The answer is yes. That is a great question. That's something I've completely glossed over and will continue to do so. Hopefully you are still watching this, whoever asked that question. But yeah, I mean, that's a simple answer. That's the easiest one, yes. Okay, somebody said maybe you're trying to connect to the HTTPS URL on the AWS container. Should be HTTP. That's just a regular IPv4. All right. And somebody else said, I think this was an answer to that question, should focus on specific DevOps tools and check others that suit for workloads. That is actually where I would be as well. All right. That is it. I want to say thank you to everybody that showed up here. And hopefully you got something out of this. It was great having you here. Sorry for my my AWS going sideways. Oh, that is going to HTTPS. I'm going to feel super. Look at that. Whoever just said that. Oh, I hope you're still on that. Okay. Who said? I'm not sure. I'm going to give full credit if their name's assigned to this. Claudio Gecko? Sorry, I'm probably pronouncing that right. Claudio, you are absolutely right. I was, in fact, trying to go to HTTPS. I didn't even notice that it put that in there. There we go. Anybody still around? 40 people that are on here and anyone on Facebook. There is my virtual machine, my EC2, running my workload in AWS. I'm very happy now. Okay, everything worked perfectly. All right, again, thank you very much. I am now done unless there are other questions. Otherwise, I would be more than happy to turn this over to you, Brittany.